In this lesson, we will connect the green decimal squares for hundredths to a decimal number line for hundredths and use this number line to measure objects more precisely. This number line has the decimals for tenths that we labeled in the previous lesson. 0.1, 0.2, 0.3, up to 0.9, and also mixed decimals. For example, 0.4 was located by using the square with 4 parts shaded out of 10. The shading ends at this point, and we label that point 0.4. Notice that the green square for 0.40 has the same amount of shading as the red square for 0.4. So when we place the green square with 40 shaded parts out of 100 on the number line, its shading stops at the point 0.4. So either the decimal 0.4 or the decimal 0.40 can be used to label this point. The green decimal square is divided into 10 equal columns, and each column has 10 small parts or 10 small squares. The number line from 0 to 1.0 also has 10 small parts, 0 to 0.1, 0.1 to 0.2, 0.2 to 0.3, and so forth. And each of these parts has 10 small parts. So the decimal for every green square with 100 parts will correspond to one of the 100 parts from 0 to 1.0. For example, the decimal for one part out of 100 is 0.01. The 0.01 is the decimal for the first of these points, the first of these 100 points, from 0 to 1, is going to be this point, which we can label 0.01. Let's look at the decimal placement for the square with 45 parts shaded out of 100. To find the point for the decimal 0.45 on the number line, we go to the 0.4, count off 5 more spaces, 1, 2, 3, 4, 5. So that point's going to be here, 0.45. So the last column of the square for 0.45 is 5 parts shaded, half of the column is shaded, and we went to 0.4 and went halfway from 0.4 to 0.5 to locate the point on the number line for 0.45. Let's locate the points on the number line for a few mixed decimals. 1.83 is a mixed decimal for one whole square and 83 parts out of 100. So we go to 1.0 for one whole square, and then go to 1.8 for 80 more spaces, and then count off 3 more spaces to get the point for the mixed decimal, 1.83. Let's locate the point for 2.58. This is a mixed decimal for 2 whole squares and 58 parts out of 100. So we go to the point 20 for 2 whole squares, then go to 2.5 for 50 more parts out of 100, and then go 8 more spaces to get the point for the mixed decimal 2.58. We can use the spaces of this number line to measure length. The length of this pencil is very close to 1.85 units. So its length to the nearest hundredth is 1.85 units. In the previous lesson, we used the decimal number line for tenths and found that the length of this paperclip was between 0.2 and 0.3 units, but closer to 0.3 units. Now we can see its length is very close to 0.27 units. So its length to the nearest hundredth is 0.27 units. Students can each be given a hundredths number line to measure objects. For example, the width of this standard sheet of paper is more than 2 units, more than 2.1, so 2.15 units to the nearest hundredth. And its length is more than 2.7, and 2.77 units to the nearest hundredth. In the first 3 lessons, we have used 2 different models for decimals. We used the region model with squares divided into 10, 100, and 1000 equal parts. The second model was number lines, and you may have seen something for the first time. We showed a connection from the concrete region model to the more abstract number line model.